Anyway, let's get right into it. So today we're going to get into science, data science, weather prediction, which is specifically Nairobi precipitation prediction. The first one which is how to get the data set, notion of oceanic and atmospheric administration. So you can just click on that. I could search NOAA. Then you can search for the data sets and see the data sets. Let's read summary, search tool. The summary does basically all of this information. So yeah, lecture observation type and the date range and then the location. Choose the summary, date range. Then you can see the full details. Yes, so as you can see, the daily summary, it comes to the air temperature and precipitation, most probably for a different location. There will be more information and that the time breaks really. And then you add to cards. And then they send it to you. And then you can take email address, verify and submit order. That's how you get your data set. So I already have data set and I don't need to re-download it. And to do what, you can just save it to GitHub. I'm going to the data set so that I'm able to retrieve it if to Colab. So this and get the raw link. Start connect. So the first thing you need is to install or data profiling, which is going to help us to get the specific information of the data set that we have, the different column names, the data we have, the data types, the number of blank fields and all that. So a model that you're going to use later, those ones that are found in SQL. So you can run it. And then what pandas, NumPy, or data profiling. It's time looking for AI library, skill learning a model. So it's really likely with them to go through several regression types because the type of machine learning that we which they use linear regression, which will take such. See supervised plan, supervised reinforcement. So customer segmentation, clustering, basket analysis, supervised tax classification, and finding GPS data, then with planning time at scale, marketing. Yeah. So supervised learning, so that's the type. Supervised it's regression classification. So we're going to be regression. And all these forms of regression. So we have Ridge regression, some regressor, heavy regressor, Bayesian ridge, tree regressor, and we'll see stats model to this. We're going to try to get the mean absolute error and try to check which is the best. So each of these have their own advantages and disadvantages, and of each of these I went to GPT to get information when they are useful. I would show you here. So, and that was just to There, Ridge Regression, which is what I used. See where I was telling you to get the specific URL for the data set. You uploaded it on GitHub, and you can see it's same here. And see if I use this link, I'm still going to get the data. So when you get it, you're going to read it with dates as the index. Let's see if it works. It's now. So yeah, to just click row and then you copy that link. First thing we're going to do is to get the null percentage for each column so that you can know what you're going to remove. So you know the column has a very large null percentage, which means that it's not really necessary for the regression in some situations. So in others, you might want to keep the information, but I'll just try to remove them because it's here in strikes. So it is going to do whether the data sets that not apply pd.withnull.sum. So it's basically editor analysis in a specific column, and then whether the shapes is the number of rows. So when you divide and then multiply by 100%, then to give you the specific percentage for each column. So you need to be paying attention to see now correct columns, which is whether the columns null percentage is less than 60. Actually, you can just try specifically to take it out. Yeah, so you can see with percentage expectations percent. It is 99%, so almost everything is empty. Tier weight means it's 0, so it has all values correct. Tier 50% are missing, almost tuning 6%. So you then see that this data set has a lot of missing values, and you're also going to see it using the Y data profile. So, and then you can check the correct columns. So we remove the ones that have a null percentage. It is about 60. So there in those so that I can view the precipitation, because that's what we're going to predict. That's why maybe it might. And then you can see whether the correct columns would copy. So this prevents an error. There's an error that you can receive when you don't put the code and just say whether it puts to where the correct columns. It might create an error. And then whether the columns you just want to make them lowercase for easier search. And then you can see the columns that you have. So T-min, T-max, T-average, precipitation, name, and station. You can see here you have no depth, but it's removed because the percentage is greater than 60. I can see T-average, it's mainly in between. It's between 80 and 50 in between. That's okay. And then you can try some precipitation. Yeah, so we've adapted some so we switch back the null values. Yeah. You can use the profiling to get the specific information for all these. So the profile, what you put in the data sets, the data oriented. So we bit of independent, bit of the weather, putting the title and explorative equals true. I forgot what that is. Just come to GPT. What is the it just provides you the additional insights and the visualizations in the several, but it just provides you with more insights. Let's run it. As you can see, down below we give you a number of variables, innovations, missing souls, rules, side, and you can see that already broken it down to the categorical and numeric variables. So you can see the different variables, see station, the name to categorical, and then you can see the precipitation, you drill number, and see it's missing 5321, 58.4%. You can see it matching go to what we had. 58, yeah, somewhere, at least it's somewhere. So you can see here, exact the zeros, the 24% win. The Dataset can be much specifications. At the end of the average, you can see at least this one has the value it has every basically Tmax, the maximum temperature, similar thing, 49.5% as we had seen, T-mean 46.7% missing. And then the interaction, so you can see how precipitation interacts with maybe T-mean. T average, you can see with zero precipitation, the average is 65, something like that. Tmax, let's see Tmax, and Tmax T-mean. And the temperature minimum between like 15 and 58, the maximum will range that's around 80. So it's actually that's what this does, the interaction, then the correlation and the missing values. So we see expectation has 79 values. Yeah. And the sample it shows you a few zeros, last rows, and duplicate rows. So yeah, that's the proper flow. Filling and I think it really comes in handy if you want to understand your data quickly, and it's under the HTML that you can even export. That's a really good thing. How would I even export land pin number? You see, don't remember anything GPT. How to export by data. Can try this. So you can see. You can leave it in. Yes, so after we consume the empty values, this is downloaded and link it. Showing you how you can download it. In the empty values, let's see, we show the number of empty values that were there, PD that is null. And it's going to do it for each column. And then I'm using backward in and forward fill again. Why we click this? This is so that you can fill a data set. We want to fill the first correct values first, and then whatever remains, you can fill them forward. So let's say the first correct value was on the 5th. The previous rows that had the none values are going to be filled with 5. So at least that is a valid information. At least there was some information that can be referred from. So that's why we're using backward fill. So if the 5th row is 5 and the previous rows had none values, they're going to be filled with 5. And then the next row, they didn't have any value. That's when now we forward fill. And let's say it started from, let's say, 2. After that row, it was a 2. We're going to fill the rest of the value with 2. So you can see we're trying to first fill the most recent value for the previous rows. And then after the value that do not exist after all the previous rows of the field, then do a forward fill. That's already a backward fill and forward fill. I'll make shrug and then this. And now if we run it, I'm sure it's going to be 0. You can get the head. And you can see if no value that's been hidden initially. Next, we're going to filter the unnecessary rows, and that will be the identifiers times the date time column, those values that have low variance, so they're not staying in either, and those ones that have high cardinality and they're categorical. So, for example, name. Oh, come on, that's not going to be important in creating the model that you're going to use. You can create filter columns for ML functioning, and it's going to get the necessary columns and regions unnecessary, it's going to be appended. You can just copy in this. In case I think I'll share this Colab notebook, but you can also be coding as we know. Just pause and copy the code and try to run it, which I'm taking my time to explain. I think in the near future, maybe when GPT they come out and take up the coding process more, I think it's going to be more necessary to be able to understand and interpret code rather than even write it. That's why I've changed from actually writing code to just writing the code initially and explaining to you how it works, because eventually the AI models of ones that are going to write the code, it's going to be a work to understand the code and try to modify it to fit your use case best. And I think that's what I'm trying to help him do. Yeah, so unnecessary columns, filter the columns for weather. You see the station at bell. It doesn't get data because we used data than index, so it won't be an unnecessary column. It's not going to be part of what we'll be putting in the model. And then next, you're going to put the index as date time so that you're able to use, can break it down to the year, the month, and the day. Then now, because they're trying to measure the precipitation, they're going to shift a value back from the precipitation column. So ideally, what we should supposed to do is values. Yeah, that's a bad name. Nice. Say how 3, 2, 5, 6. And towards this is going to be target shift in the -1. Whatever is here will be put here. So this is the precipitation and this is the target. There. So we're going to shift this value here, but by -1. So by the previous value. So if here is 6 in targets, the rule becomes 6. That's why it's going to be feeding 6. Okay, it's going to be 6. Then here 5, here 2. At the end, there's going to be a missing value here. And that is why we are going to do the forward fill to fill this null value. So here it's where this 6 will come back here too. I think that's understandable. Yeah. If you don't, you can just hit me up in the comments. And so now with that, we're going to create a copy of weather. So let's kind of put a different part of memory such that even if no matter how much I adjust weather 1, it's not going to affect the original weather. So we're going to get now predictors. In the necessary columns, we extend target so that you don't have to predict something with a target, a predictor, and then want to get the predictors. So we already had our necessary column, station and name, and now it's target. And the predictor will be weather 1, what columns, what is not in weather 1, the columns that are in unnecessary column. So these specific columns that are in unnecessary columns, remove them from weather 1 and return those columns, and those will be our predictors. And that's what we have is we have precipitation, tailwinds, Tmax, and Tmin. So we run this there. I haven't run anything. And details of the target. So now we want to get the mean, median, and range so that we can compare that to the mean absolute error that we get. So you can see the mean 0.18, the median 0.04, and the range is 18.18. So there is the data is skewed to the left, whereby the more data is within the zero, then that makes sense because we had a lot of zero. You remember 28% of zero and percent values aren't there. So that means when you do like the backward and forward flip, most of the value will still be zeros. Yeah. That. So now we create a backtest, and this is because we're using time series data as split word for word. So we want to predict the data. We want to predict using past data and not future data, and that is where we backtest. So we're going to be getting certain rows up to that point and then training them, and then the test will be a certain number of rows after. So you're consistently testing with trained data before and not after. That's what this backtest is. So you receive the data, the model, and the predictors, the stats, and the step. So as you can see, all predictions, that's going to be all the predictions. And for I in stats, data to chip zeros, number of rows, and then the step. You can see for the training data set, we just get everything. Ti and I is the start to 650. And then we're testing the test data will come from I to I cluster. And if you have a smaller data set, you can just remove start and fix step, or even leave the step that reduce the start. Yeah. Or just instead of having a for loop, then just have one train to train a certain level and then to test for the rest if the data set is small. But since this is a large data set, I think this can suffice. And then model that fits, to train the predictors and with the targets. And then after that, you just do the prediction. But so it's going to be battered predictions. And this returns it in NumPy, so you have to convert it to pandas. I'm grinding it to two decimal places so that it doesn't take much space at start using the notation. 1.8 plus E1. Yes, we just do this to just check the NumPy to see how it is returned. They're converting it to series with the index being the test it index, which was the late time. And then we're going to combine the predictions and the targets, and with the axis equals 1. And it's to ensure that this becomes one level. When you concatenate it, it's going to be 1. And then the combined column have the prediction is just an end. So just target will be the actual and print the prediction. Create a new column called difference, which is the absolute difference between the prediction and the actual. And then you apply it to all predictions. And once that's done, I'm going to concatenate all predictions. So here we see our past regression type. So that the video becomes shorter, I'll do Ridge Regression first, and then I'll create another video for other regression types. Or I'll do Ridge Regression and Bayesian and Ridge, because they're similar, they're related. Yeah. If you define the models, this is just a function that's taking these alphas. So you can see what the alphas do. Through regularization, controls the strength of the regularization applied to the model. This regularization helps to prevent overfitting by penalizing large coefficients, leading to simpler models that generate better to-do data. So if you have a high alpha value, it increases the penalty and reduces to 0. So the model is simpler and overfitting becomes less probable. But don't make it too large so that we do not underfit the data until it becomes too down. And then low alpha value, we fit that data specifically into the training data set received. So it's increasing the chance of overfitting. And if alpha is 0, to just reduce it to ordinary least squares regression. What's the difference between that and linear regression? Such you can see the specific alpha values 0, no regularization, complete-wide sum, that's y more balanced, and it's the default, 10 or higher, strong. So you can choose the best alpha using this, but instead of this, I decided to have a formula that is going to take in the different alpha values and get the mean absolute error for each model with a specific alpha for its regression. So what's the difference between this? It's linear. So let's see what linear regression is. So the independent variables x and a dependent variable y, and you're trying to fit to the linear equation. Basically, we're equal to mx plus. I think I'm going deeper into this, and I thought I would. Ordinary least square. So it's estimating the parameter to a linear actual part. So we can try to make the most of this and also search. Ridge regression now adds the penalties to the coefficients to handle the multiple linearity. Now that you wrote the alpha does, okay, understand that. I have some understanding. But let's see where is Ridge. So we're entirely correlated. That's why I prefer sheets, because we can see we have temperature max, temperature low, temperature land precipitation. So you can see that's quite related. We have a large number of predictors with a high variance. So the zero, so 18.1 is the range, linearity, high dimensional data, event overfitting, variance. Small sample size. That's really interesting. Yeah. Then this what's alpha model reach. And then you have the model come back test in the data of the model and the predictors. And then we get the difference. And then the mean absolute error. You can store model in absolute alpha 0.1, 0.1, 10.5. It just gives me so that you can understand how much the variance in alphas can affect your results. And this is just the predictions, actual value prediction difference, and they'll be ordered in descending order. So they want to the largest difference first. It's the sum that have in zeros. And you can see almost over to 0. Try and see 1, 0, 7, 5. It's increasing. And then that try to predict a value, a specific value tomorrow. So basically what I want to do, I deleted my notes, my paint clue, but picture it's drawing blind. We had our target shift to the previous row, but so when you have a specific row, you're trying to predict a value for the next day. So if I'm at a certain row, I'll be trying to predict the target for the next day, unless there's no value in the next day, but that is ideally what to predict tomorrow does. So it's the predictions into an array. And this is because there are several models you use different outputs. Then you can see the recent data. So we're passing more specification, the predictor value shape. So this ensures that it's one row and like that you want to get all columns for that specific row. And then the current state will be whether the child lock the position of its name in that of our index. And that's how we get the index, the position, the name of the index. In this, we work with what we need to do with the data offsets, the equals 1 to get the next date, because we converted the index to a date time field. If you don't convert it, it's going to throw an error. So current state plus date offset is equals to 1. And then we come to the prediction. So modeling models, prediction equals models that predict recent data. And that will be the predictors here. And what you're predicting is the precipitation for the next day. So the data frame it's going to have the prediction index will be the next day, and the columns will just be prediction and the specific model. That it leaves the column name. They should be index and they should be value. So it's just a row, the column name and the value its index will be the next day. Then we combine all the predictions. Axis equals 1 means that it's going to be 1 row. And since the index is 1, it's going to fit it to that row. So then the next dealing, whether the index, so if the value the next dealing, whether the index, so if it's a index, if it actually exists in our data, because I might search for value that does not exist. Actually, I should do something here too, so that I ensure that the position is within the length of the rows. So I'm going to do that. It's less than negative len. And position. It's that you can just draw an error. So this error can increase a value of error. Yeah, so you get the recent data, please, and then the current dates. The main reason I'm using negative is because in iLock, if I say maybe -5, it's going to start from the lowest, from the last row going up. So negative can work until less than the negative length of the row. It's going to work till the first row. It's backwards. We use negative. So it starts from 0 to, let's say, 9. So certain values. If we put 10, it's going to be wrong. So that's why this was wrong. But I would still have used 2 and weather. So this doesn't have any effect. It's just the number of rows. It's similar to len weather. Don't worry about that. That is the auto complete feature. Whether it's there, yes. So if next day another dot index, that's when and the actual precipitation. So let's run that. Then you can get the models from the results. Results model. Now the results was return 0.1. That model reach. So we just want to get this specific by the range. Turn into results. And then you get a result specific. So it's 0.1. And then get the model, which is range. And you're going to switch in the list. Exactly. See that, and then I want the date frame tomorrow. Let's run it. I think it's quite close, but I will try. I think this is one few ones that I got that one. Let's try another one. I will try it 3. Let's see 0.0 and then 0.0. So, and if this is in millimeters, I hope it's not big of a difference yet. Now that is why we were comparing it to. I wanted to do this so that I can compare the absolute error that we have here with the information we got from the dataset. So
1 million parents for see the mean absolute error based on the mean the accused, so that means that slightly above average, it's very above average. And the median, so you can see the median being 0.04, which means that the mean absolute error for Ridge regression way above the range. And then for the range, at least you can see that the rise is huge. But it was on the difference between the mean and the median. It shows that this is a skewed data set more towards the view. Keep the left at the end. It's can confirm. Jesus Christ. Skew to the right. I would expect you, babe. It's very skewed. Here. So it's skewed to the right. So that very low values that are high, but very high values that are low. If so for that, that's skewed. And then left skewed is when it's more to more values towards the high side. That's the issue. And as we had seen, it had 60% non-valid in our body. So it means that the meter set specifically for precipitation, right? But yeast, it's also not, but it's not performing that. It's not bad. Next, I can show you how to do the rolling. So now we more predictors to see if we can improve the accuracy. Let's see that. You can just type it in the comment section, and then once you really mean it's expand B, just check it out, and from there we can see the other regressors with some regressor and see how it affects. I mean absolute error. And Bayesian Ridge, I will show you today, but the video has become a bit long. Bayesian Ridge, 2D regressor, and zero inflated Poisson. And on here, you may see actually, I'll share links once I'm done explaining all the codes. I won't share it for this video, but I'll share this collaborate working on next. As I had said, you could just be pausing and typing as you need, but I'll share the HBook after we're done with everything. I think that's all for today. X, City Tech. Yes, so here's my X feed. I have 0 posts, 0 view, 0 feed. I haven't put anything. I just started it yesterday, and I'll be posting the links for videos here too. And I want to start a plan for going through tech papers weekly, and I'll be posting my highlights here and new things that happen in tech. So if you're interested, you can. They don't worry. 0 posts, but in the next few days to lump list. And OPIC from humans. Yeah, it's going to be very free. We'll check. And hopefully we create a good community. We can interact through. Yeah, so that's it for today. See you next time. How to increase the column. Yeah. Have a great day.